Okay, we're going to do notes today over the parent functions. You focused on each of these last year in Algebra 2, so we're going to just make sure you remember all of them. They're important as you do extra things with these functions throughout the year in pre-cal. So I have the first five showing here on the screen. You might want to check your work, make sure you have the same answers that I have. Kind of have it in your brain memorized what the equation is, the name of that equation, what the graph looks like, what the domain and range for each of these are. And then, we kind of focus on critical points before we do any transformations. We're going to make sure you know what odd, even, and neither are here in a little bit and further in the notes. So might pause the video, make sure you have the same answers that I have, and then I'm going to scroll down so you can see the next 6. Okay, the next 6 are showing on the screen, so you can check your work with those. One that we probably didn't focus much on in Algebra 2 was the greatest integer, so we're going to talk about that a little more on the next screen. Okay, so the greatest integer function, we use this symbol to as a notation for the greatest integer function. Sometimes it looks like this. We have a graph here so that you can see what it looks like. Notice that you'll have an open circle on part of it and then a closed circle on the other parts. That keeps it a function because you can't have x's that repeat. We use every single x, so the domain is all real numbers or from negative infinity to infinity. For the y's though, we only use integers, and this is how we write that. Y is the set of all integers. That little z symbol just means integers. Okay, so if you'll notice here, we only use like the numbers 0, 1, 2, 3, no decimals or fractions. Some real life examples of when we might use this function is, for example, if you're going to pay for postage based on weight. Let's say you're going to mail a package, and if the package weighs somewhere between 0 and 1 pounds, you're going to pay $0. If the package weighs somewhere between 1 and 2 pounds, you're going to pay an extra $1. If the package weighs somewhere between 2 and 3 pounds, you're going to pay an extra $2. So that's just an example of when we might use the greatest integer function. We also have on here a cell phone plan, a utility bill. There's a lot of different examples just to give you an idea. Okay, so now let's focus on even and odd functions. Okay, so an even, you need to be able to classify a function as either being even, odd, or neither, as this is saying here. You need to be able to do it graphically or algebraically. So we're going to first show you how to do it graphically. If it's an even function, if you look at your y-axis right here, you should see a mirror image on either side of that. That makes it an even function when it's a mirror image on either side of the y-axis. An odd function, if you spin the picture upside down about the origin, the graph looks exactly the same. So if you look right here, that's the origin, and if you spin this upside down, you should see a mirror image. I always think about it like this. If you look in diagonal quadrants, if you see the exact same image, then it's an odd function. All right, let's do some examples. Okay, if you look at this first one, this is our y-axis, and you should see a mirror image on either side of that axis. That makes this an even function. On the next one, if you'll notice right here is the origin. You should see, if you were to spin it about that origin upside down, you would see the exact same image. Or think about it like this. In diagonal quadrants, you see the same thing. And also in these diagonal quadrants, you see the exact same thing. So these are odd, or this function is odd. On the third one, if you look at the y-axis, you definitely don't see a mirror image on either side of it. If you think about spinning it around the origin upside down, you definitely don't see the same thing. There's not the same thing in diagonal quadrants, so this would be considered neither. All right, let's do it algebraically. Okay, if you're going to do it algebraically, you're going to need to replace every x with a negative x to analyze it. If it's an even function, when you replace the x with a negative x, you get the exact same function that you started with. For an odd function, when you replace every x with a negative x, you'll notice that the sign of every term changes, and so if it was positive before, it becomes negative, or if it was negative, it'll become positive. So we've typed up directions for you to follow here. You can read through those. I'm just going to go ahead and do the examples with you. Okay, so starting with example 4, you're going to replace every x with a negative x and see what happens to the function, how it compares to the original function. Okay, so we start with this first x, we replace it with negative x, then we do the operation that it has done to it in the function, so it gets cubed, then we'll do minus another negative x. Okay, when you cube a negative number, it stays negative, so that becomes negative x cubed, minus a negative x becomes a positive x. Now we need to compare this to our original function, and if you'll notice, the sign of every single term has changed, so that makes this an odd function. Okay, let's do example 5. We're going to replace the x with a negative x. So that becomes a negative x, do the operation, which is squaring it, and then adding 1 to it. All right, so simplifying that, when you square a negative value, it becomes positive. So we've got a positive x squared plus 1. If you compare what we just did to the original, you'll notice that every term looks exactly the same as it did originally. So that makes it an even function. All right, let's do example 6. We're going to take every x and replace it with a negative x. So we've got 5 minus 3 times negative x. All right, so that when we simplify that, that becomes 5 plus 3x. So if you compare what we just did to the original function, the 5 has kept the same sign as what it did originally, but the 3x has changed signs. It's different right here. So because it's not doing the same exact function, it's not even. Because every term did not change signs, it's not odd, so that makes it neither. All right, let's do a practice graph. All right, so we're gonna complete these graphs by making it even and making it odd, and I'll do them in 2 different colors just so we can see it. So to make it even, we first have to focus on the y-axis, and we want to make this graph reflect over that y-axis. So you'll have this point that's on the y-axis will stay there. Another point I might focus on is that one right there, which is over 1, 2, 3, and then up 1, 2, 3, 4, 5. So we're going to go over 1, 2, 3, and up 1, 2, 3, 4, 5, and put a point here. If you go over another 5, all right, so if you go over another 5, or over 5, and up 2, you should have a point right here. So this would make that function even because it's a reflection over the y-axis. So even is in blue. Let's change our pen color to red. And now let's do the odd function. So the odd function focuses on the origin, and whatever is in this quadrant, you'll see that same thing in this quadrant over here. So we went over 3 and then up, and before we went up 5, so we'll go down 5, put a point here, and then you'll have a point here. So this will make an odd function with that original part right there. So the red makes that odd. All right, let's do the same thing over here. We're going to focus on the y-axis to make this even. I'm going to draw it real quick in blue. Okay, so that makes this function even because it's a mirror image around the y-axis. Okay, let me draw in red the odd part of that. All right, so there it is. Diagonal quadrants have the same image drawn, and so that makes it odd, the part in red. All right, let's do number 9 real quick. Okay, so this is, if you'll notice, I've highlighted the y-axis in yellow, and then I made a mirror image on the other side of the y-axis. So that makes the blue part, makes it an even function. Let me do the odd part in red. Okay, so this is drawn, the odd part's drawn in diagonal quadrants, and it's as good as I could get for a mirror image in that quadrant. So the red part is odd. All right, so that's our notes for today. Thanks.